Welcome to the second video of Insights into Meshing. In this video, we are going to cover what is the meshing and the process of meshing. We'll also look at some different terminologies which are involved with meshed body and unmeshed body. So let's start with it. So what is meshing? It is a splitting of an extended bodies into smaller bodies. If you have not looked why the meshing is required and why or what is the purpose of splitting an extended body into smaller bodies, it is recommended you look at the video of why meshing is required from physics and mathematics point of view. So now we have the purpose that we need to split an extended body into smaller bodies. So now how will we go about meshing? So we'll use some grid lines to split the body. So grid lines are a set of lines which we make on a paper or anywhere. They may be rectangular or they may be perpendicular to each other or they may be curved. Different kinds of grid lines are possible. The simplest will be the rectangular grid lines. Then the process of generation of grid lines and grid points is simply called as meshing. What are the grid points over here? The grid points are the intersection points of where the grid lines are intersecting, right? Then, so the meshing results into generation of small bodies, which are called as elements. So this is the first terminology for you, elements. And this elements is the terminology for the simulation software. Now the intersection of the grid lines, which generate the grid point, which are usually called as nodes in the terminologies for simulation software. So there are two things we need. We need elements and we need nodes. And how do we get them? We get them from making grid lines or drawing grid lines. Though there are some other ways also to generate nodes, and those are more manual ways. So we'll avoid looking at those from the starting. We will look at it from the later part of this series. So that's the basic process. We make grid lines or we draw grid lines. And where do we draw the grid lines? We draw the grid lines on the body. So if I have a watch like this, on the front end, I'll make a grid lines like this. They may be curved, they may be rectangular, etc. And drawing the grid lines will make the elements and nodes. The grid line selection is the most important or most critical part in any simulation. The grid lines should also result into small enough small elements that they can be considered as point mass, and there is ideally no change in the value of the parameter, the input parameter within that element. So in that element also there are infinite number of points, but we have made an element in such a way that the input parameter values and assumingly the output variable values do not change drastically, or the gradient of those values are small inside the element. Inside the body, from one end to the other, there can be some, or there are expected changes, but inside an element there should be least amount of changes. So that is the most critical part. How do we make a proper element and proper representation of extended bodies into a set of elements? So that's the end of it. In the next video, we'll look at the different various models you can work on. So various models will be some static, dynamic, etc. So we'll end over here. Thank you.